Hello everyone, welcome to our channel OnlyPhysics JEE Grad. So today in this video we'll be discussing JEE Advanced PYQs from the chapter Rotational Motion. So this will be the first video on this chapter. And the topics will be covering our center of mass, okay, and there will be questions on collisions also, okay. So let's start. So there will be 20 questions we'll be discussing in this video, but there are a total of 37 questions on this topic. Okay. So let's start with our first question. So this will be our first question, right? So in this first question we have, let me zoom in a bit. I think just give me a second. Okay, perfect. Now in this question we have a ball of mass 0.2 kgs, right? Rest on a vertical post. So this is a vertical post by height 5 meter. A bullet of mass this traveling with a velocity v meter per second in a horizontal direction hits the ball. Okay. So after that, the collision ball and travel independently. The ball hits the ground at distance 20 meter. Okay. And the bullet hit at a distance 100 meter. Okay, perfect. So look, in the first, we can conserve momentum, right? So initially, the bullet, so initial momentum equals to final momentum. So initial momentum of the bullet was 0.01, its mass times the velocity v is equals to final. Let's say this is the velocity of a bullet plus the ball. Okay, so let's say small b represent bullet and capital B will represent velocity of velocity of ball. Okay, capital B. So mass is 0.2. Now, as we see that they only have the horizontal velocity, right? Because the collision occur in the horizontal direction, right? So both will have the only the horizontal velocity. Now, they don't have vertical, so let us find the time when they hit the ground. So it will be root h by g, root 2h by g. So it will be 2 into 5 by 10. So this will be 1 second. So after 1 second, they will hit the ground. Now, let's first find what distance this bullet is traveling. So bullet is traveling 20 meter. Is it ball? Yeah. So ball is traveling 20 meter. So we can write the range is equals to 20 meter will be equals to velocity times the time. This will be the velocity of a ball, right? So this will be capital B. So VB, so VB turns out to be 20 meter per second, right? Because time is 1. And now for the bullet, right? So it will be 100 is equals to VB into T again. So VB, so V small b will be 100, right? Let's put all those values here so we can find the capital V. So it will be 0.01 into V is equals to this is 100 into 1 by 100, so this will be 1 plus 0.2 into 20, so it will be 4, right? So V will be 5.0.01, so it will be 500 meter per second. Okay, so quite simple question it is. Let's move on to question number second. Okay, question number second. Now this is a quite famous question, okay, and easy, of course. So we have these are our axes, right? And this is the center, and this is a road. So let me rub this. This is the origin. Okay. Now have given the coordinates like this. Okay, the coordinates of centers of different parts, right? So we have to find the y coordinate of the center. So this will be simple. Y of center of mass will be, let's take y coordinate of hole. So outer circle will be m into 0 plus left inner circle will be, so outer circle is y coordinate is 0. So mass of the outer circle is 6m, right? So mass of the outer circle is 6m. Then left inner circle, the coordinate y is a. So we'll write m into a plus right inner circle, the coordinate of y is again a. So m into a plus vertical line, it's 0. So m into 0 plus the horizontal line, it is m into minus a, and divided by the total mass. So total mass will be 6, 7, 8, 9, 10. So it will be 10m. So these will get cancelled, and this is already 0, this is already 0. So we get a by 10 is our answer. Okay. So again, a quite simple question, right? So let's move on to our third question. So we have this. Now in this question, there are two particles, whose mass m1 and m2 in a projectile motion. They have the velocity v1 and v2, okay, at equal to 0. Then at t naught they collide. So I don't know like from where they have thrown. So let's say this is v1 and this is v2, and after some time t naught they collide like here. This happens at t equal to t naught, and this happens at t equal to 0, right? The velocity becomes v1 dash and v2 dash at a time 2 t naught. So after that something will happen and the velocity will become, so this velocity is v1 vector and this velocity is v2 vector. So look, there are a lot of data is given, right, while moving in the air. So if they are moving in air, g must act in the downward direction, right? Okay. So the value of impulse. So look, if we consider these two particles as a system, so only the force, the net force acting on both of them will be m1g plus m2g, and it will be in the downward direction, right? So if we have to find the impulse for the total, right? If nothing is given, so we'll go the impulse from 0 to t naught, right? 0 to 2 t naught. So it will be integral f dt. And look, f is always constant, so we can take it out from the integration, and it will be this integral dt. And the time is what? So time is, total time is 2 t naught, right? So m1 plus m2 g into 2 t naught. So which option is correct? C is correct, right? So C will be the option. Okay, all the other data is just, you know, we don't need it actually. So this question is quite simple again. Let's move on to question number fourth. Okay, so we have two questions. Let's solve first one. We have an isolated particle of mass small m is moving in horizontal plane xy, okay, along the x-axis at a certain height above the ground. Okay, it suddenly explodes into two fragments of mass this and this. At an instant later, the smaller mass, the smaller fragment is at y 15 centimeter. Okay. So look, we have a plane like this. Okay, let's assume a plane like this above the ground. So they are moving in xy plane. So let's consider this. Let's say this is x and this is y. So this will be z, right? And they are moving in xy plane. So let me make a plane for you guys. So let's say this is our plane. Okay. So this is the plane. Now particle is moving in this plane. Okay. So particle is moving in this plane and its velocity is in x direction. So like this, it's moving like this. Okay. Its velocity is given or not? Okay, nothing is given, right? So let's say it is moving with a velocity v. Okay, now it suddenly explodes into two fragments of mass m by 4 and 3m by 4, right? At an instant later, the smaller fragment is at y equals to 15. So one fragment, uh, let's say this is moving like this, right? So one fragment is here, right? So this is y equals to 15, and this is the smaller one, so it's m by 4. Okay, now look, how will this small fragment reaches here? Okay, so there must be some force which acted on it during the explosion, right? So the other fragment must move in this direction, which is in minus y, right? So we can simply conserve momentum in the y direction. Okay, so P initial in y is equals to P final y. So initial in y there is nothing, right? Because it is moving in x direction. Okay, so look, this particle is in plus 15. So we can write m by 4, right? Let's say it has taken t time, but we will not consider it. So we'll just consider the x. Okay, so you can write 15 by t also. It does not matter actually. Okay, so this is in plus 3m by 4, and this will be moving in the minus y direction. So we'll just write y. Okay, y by t. Okay, so I'm saying that the instant, let's say after the instant later, it's the t time. Okay, so look, at t time it has moved 15 meters in the y. So I just written the velocity is 15 by t. Okay, so 3m by 4, let's say it has moved in a y direction, in a distance y in that same instant, right? So it's t. So automatically this formula will give our answer. So m by 4 will get cancelled. So we will have y equals to minus 15 by 3. Minus 15 by 3, which is minus 5 centimeter. What does it say? That if after the explosion, if 3m by 4 moves 15 meter, m by 4 move 15 meter, then 3m by 4 will move in the opposite direction by a distance 5 centimeter. Okay, are you getting me? So this is quite easy question, right? Now this question they have given in terms of like coordinates, right? And we know a particle is moving, then v is proportional to x its position, right? So we have used this, but still I have used the velocity here. I have taken the instant later as a t. So this situation is like easily understandable. Okay, let's move on to our fifth question. So this is our fifth question. Now we have two particles A and B initially at rest moving towards each other with a mutual force of attraction. Okay, so they are initially at rest. So initially at rest. So this is V0, V0. We say B. Okay. Due to mutual interaction at an instant, the speed of A is V. So what happens after some time? The speed of A is V. Okay. The speed of B is 2V. So this is 2V. Right. The speed of center of mass of the system. Okay, look, if we consider this as a system, there is no external force. So external force is zero. So if they are at rest, that means velocity of center of mass must be zero. And if there is no external force, so at all the time, velocity of center of mass must be zero. So this will be quite easy question, right? Okay, perfect. Let's move on to our sixth question. Right. So let me zoom in a bit. Okay. Sorry. So we have a block of mass m. We have a block of mass m. So this is of mass m, okay? A circular cut. So this is a circular cut. The block horizontal on a fixed table. Initially, the rigid edge of the block is at x equals to 0. The coordinate system fixed to the table. A point mass m is released from the rest at t. Okay, it slides down, then right. So what happen is this start to slide down. So it will move like this, and the block will move in the backward direction. So it will happen, right? Because initially they are at rest. So the in the horizontal direction, the momentum is conserved. Okay, so if this particle moves like this block will move in the backward direction, and hence center of mass should be at rest, right? So it's saying slides down when the mass loses the contact with the block. This its position is x. Okay, so look what happens is this is the initial situation, and the final what will happen. Let's say this is our x equals to 0, right? So so mm, like this. So this part should move like this, and the particle should be here, right? So it's like this. And in the question saying this is the x. Maybe we have to find this x. Okay, let's see. So first let's find the velocity of the point mass m is. So we'll calculate this. Okay. So let's first use energy conservation. Okay. So total energy initial equals to total energy final, right? So initial total energy is how much? So let's say this is the, you know, our u equals to 0. Okay. Now look, this mg will have some, this capital M will have some potential. So let's say the center of this is at height h. So we'll have 0 plus mgh will be the minus is equals to. So this particle has moved downward direction in by distance r. So we'll have small mg minus r. The potential of this block will remain same. So it will be plus mg minus h. And the small particle will have kinetic energy like this. Okay. This capital block will also have a kinetic energy. So it will be half capital M in this direction. Let's say this is capital V square. Okay, so this will get cancelled, and we have this. So we have mg capital R is equals to half. We can take common, and this will be m plus m small v square plus capital M capital V square. Okay, so we say this is moving with a small v, and this is moving with a capital V. Okay, now let's use momentum conservation. Okay, so momentum conservation is simple. Initial momentum is 0, final will be mv plus, and this will be of course in the minus direction, so it will be plus m minus capital V. Okay, so simple will get V as small v upon capital M, right? So if you put this value here, if you put this value here, we'll get, if you put this value here, we will get small m g r is equals to half small m v square plus capital M, and this will be small m square, capital M square, small v square, right? So this m will get cancelled, and one m will also get cancelled, right? So we'll simply get this will be 2gr is equals to 1 plus small m by capital M, right? And 2v square. So we'll get v as a root 2gr upon 1 plus small m upon capital M, right? Okay, yes. So A option is matching. Now, let's move on to our B option. So B option is saying the X component of displacement of center of mass of the block, capital M, right? So we know, right? Okay. Oh, just let me adjust it. Right. Okay. So look, this particle has moved forward and this block has moved backward. All right. And look, initially the whole system is at rest. So velocity of center of mass must be zero. Velocity of center of mass must be zero. That means the position of center of mass should be constant, right? So position of center of mass must be constant. So let me use this thing here. So we will have the position of center of mass will be, let's say this small particle has moved x here, right? So look, what happens is this particle, small particle, if it has moved x with respect to block, yes, with respect to block, capital block, right? But the capital block has moved in some backward direction, right? Are you kidding me? So how will you solve it? So how will you solve it? Now, uh, so look, if I sit on this capital block, what will I see? That this small is moving capital R distance in towards right. Okay, so we can say this small object is moving in right direction by distance capital. Okay, but what then if I go outside, like if I see from here, so I will see this capital block has moved backward by a distance small x. Okay, if this has moved backward by a distance small x, it must have taken this small particle with itself. So actually this small m has moved r minus small x in the right. Okay, and this capital has moved backward by distance x, right? So let's use this data. So we have m into minus x plus small m into r minus x. I'm just using the formula of to find the position of center of mass, right? So it will be in the x direction, so I'm just finding the x divided by capital M plus small m, and we know this is constant, right? So I'm saying, like, let's say the center of mass is at origin. Okay, let's say center of mass is at origin. So this will be zero. So we have this mx and this is mr minus x, right? So you can say this is a delta x. So this will be delta x, right? So this will be uh, right. So the x is what? Displacement of this capital M, and r minus x is the displacement of them. So it is zero, right? So we have uh, minus mx plus small m capital R minus small m x. So these term will get go here. So it will be x is capital M plus small m divided is equals to small m r. So x will turn out to be small m r upon capital M plus small, right? Are you getting me? So first I sit on this block and then I have observed this small particle. So what I see is this particle has moved in a horizontal direction by a distance r. Then when I uh, start to look it from the outside, I'll see this block has moved a distance small x in the left direction. So it must have taken this particle with itself by distance x. So the net movement of this small particle is actually r minus x. Are you getting me? And this is the displacement. But the displacement of center of mass is zero, right? So delta r is zero actually. So I will use the data. Okay, vertically there is no motion, only in the horizontal. So that is why I have written here delta x of center of mass. So B option is correct, right? So x is in backward direction, that is why it is negative. Perfect. The position of point mass is this. No, the position of point mass will be r minus x. So if you subtract r from this, so you will get r minus x is equals to r minus small m capital R upon capital M plus small m. So we'll get capital M R upon capital M plus small m. So this is wrong. Okay. The velocity of block capital M. So that is simple, right? If you put small v here, if you put small v here, you will get the answer, but it is not same. So this is again wrong. Okay. So this question is quite simple again. Okay. Now let's move on to our next question. So this question was sixth. So this is our seventh question. Okay. Now let's see what we have here. So there is a thin ring of mass capital 2 kg. So this is of 2 kg. Of radius this is rolling without slipping on the horizontal plane. So it's rolling actually, right? A small block ball of mass this moving with this positive hits, right? Okay, so perfect. So what happens? Let's say this is our ball. Okay, as it is moving in a horizontal direction, but finally it is moving in upward direction. So what will be happening on this ball? That the ring will apply a force F1 in this direction and F2 in this direction. Due to this force, the horizontal velocity becomes zero, and due to this force, this ball will get a vertical velocity, right? So similarly, the same situation must have happened on this, but in opposite direction. So F1 must be here, and F2 must be in downward direction. Okay. Now already there are certain forces acting on it, like normal, right? Mg like this. Okay. And look, this is moving like this with a 1 meter per second. Are you getting me? And it is also revolving because in the question it is saying it's pure rolling. So it is rotating with omega. Are you getting me? Now, what will happen? Let's see. Let's check the option. So the ring has pure rotation about its center of mass. It means this 1 meter per second should be zero. So let's use the conservation of momentum in the horizontal direction. So initially, this ball has mass 0.1. So initial momentum must be equal to final momentum. Initial momentum is 0.1 into 20. The final momentum. I'm considering, okay, so initial, so this is in only in x direction, okay, only in x direction. Okay. So initially this also has a momentum in left direction, so we'll be subtracting it 2 into 1. Final, there is no horizontal velocity of this small ball, right? So I'll just write 0.1 into 0 plus 2 into v. Let's say this is finally v final, okay, of the ring, right? And so the final velocity of the ring. So this will be 2 minus 2. So this is 0, 0. So VR turns out to be 0. Means the finally the ring is only rotating. Okay. So the final situation is like this. This is our ring and it is rotating like this with omega only. So there is no velocity. Okay. So it's just revolving at this point. So ring has pure rotation about center of mass. This is correct. Okay. Next. The ring comes to a complete stop. That is wrong. It will be rotating. Yes. And also the interesting thing is this F1 make it stop. F2 will be rotating it more. So it will be rotating like more. Okay. Yeah. Next. The friction between the ring and the ground is to the left. So what happens? Look, this is rotating. So friction must be acting in backward direction to make it stop, right? And what happens just after? So it's asking immediately after the collision. So immediately after the collision, friction start to act backward. And then what happens? It start to move like this, and this is getting less and less and less. Okay, so that is like after certain time. But in the question, it is asking what will happen immediately after the collision. So immediately after the collision, friction start to act in the backward direction in the left hand. So C is also correct. Okay. Next, let's check this point. There is no friction between ring and ground. So this is wrong. Friction will be active. Okay. So A and C are correct. So A and C are correct. Okay. So this question is quite nice to understand your concepts, right? So look, we are solving a lot of question with the conservation of momentum, right? So this is actually we are studying about like conservation of momentum. Okay. But for the rigid bodies, okay. Let's move on to our eighth question, shall we? So here, okay, perfect. So this is our eighth question. I'm sorry. So if the resultant of all external forces acting on a system is zero, so we have F external is zero. That means momentum is conserved, right? So momentum is conserved or momentum is constant, right? Then from a inertial frame, one can surely say linear momentum of system does not change with time. Perfect. So he is correct, right? Next, the kinetic energy of system does not change in time. Okay. So look, F external is zero, right? And we have system of particles. So what happens is you must understand this. We have two cases. So let's say we have case one where we have only one particle. We have only one particle, or we can say we have a rigid body. We have a rigid body. Then the work done by internal forces is zero. Okay. And in this question, it's saying there is no external force, so work done by external forces must also be zero, right? So in this case, the kinetic energy will be constant. But if we have system of particle which are not rigid, so what happen? There can be internal forces which do some work. So work done by internal is not zero, right? So there are a lot of example for this. So example first is a spring mass system, right? Second, SHM, right? Third, friction. So in these cases, there is internal forces in the system and which does work. So kinetic energy may not, uh, so will not remain constant. Okay, so it will change. So it does not change. So this option is wrong, right? Let's check the third option. Angular momentum of system does not change in time. So look, if say F external is zero, torque external may be zero or may not be zero. We don't know, right? So if torque is not zero, how can angular momentum be the same, right? So C option is wrong. Next, the potential energy of system does not change in time. So again, this is the same question, right? If there is SHM, then kinetic energy will be converted into a potential energy and so on and so forth. So this is also okay. And if there is friction, then definitely kinetic energy will start to decrease and maybe potential energy may be changing out. We don't. Okay, so only A option is correct. So this question is very interesting. Okay, it's a pure conceptual question. Let's move on to our ninth question. Two balls having linear momentum P and this undergo a collision. So if I want to find the initial total momentum must be equal to final total momentum, right? So initial is P I cap minus P I cap. So it's zero, right? So phi total momentum final must be zero, right? Now question is saying which is not allowed for any non-zero value of this. So look, these A1, B1, C1, right? These are not zeros. They can be positive, they can be equal, they can be negative. Okay. So it's saying the final momentum. Look, the sum of these. So we can say so P dash 1 vector plus P dash 2 vector. The sum of them must be zero. Let's check. So for A, it cannot be zero, right? Let's say A1, A2 will get cancelled, B1, B2 will get cancelled, but C1 will not. So A is not allowed. Okay, let's check B. So look, it may be possible that these two cancel. So this is allowed. Okay, so this is allowed. This is not allowed. NA, I'm writing NA. Now this. Is this allowed? So A1 will get cancelled to A2, B1 will get cancelled to B2. But this, what will happen? This will become minus 2C1. Minus 2C1 cube. So this is also not allowed. Are you getting me? So this is also not allowed, right? Hmm. Okay, no, no, no. So C1 minus C1. So they will get cancelled. So they will get cancelled in this. So this is allowed. This is allowed. Okay. So A1 equals to minus A2, right? B1 equals to minus B2. It's possible. And this C1 also got cancelled. So this is also allowed. What about D? So for D, yeah, so in this D, B1 plus B2 becomes 2B1, which is not allowed. So this is not allowed. Okay, so which options are allowed? B and C are allowed. A and D are not allowed. And this question, this is asking not allowed. So answer will be A and D. Again, it seems like we have to solve something, but this is again purely conceptual question, right? So this is it is an interesting question again. Let's move on to 10th question. Right. So we have 10th question. So there are two blocks, each of mass m are connected. So this has a mass small m, this has also mass small m. The natural length and spring constant is clear. The blocks initially are resting on a smooth horizontal floor with the spring at its natural length. Okay, shown in a figure. A third block with the same mass is moving with the v. Okay, and provides elasticity. Okay. So if they have the same mass, if both have same mass, then velocity will get exchanged. Okay. So what will happen? You must understand the situation first. So immediately after the collision, they start to move with V and it start to compress this. And as soon as it compresses, this block will experience a mass, a force kx in this direction, and this experience a force kx in this direction. This is still moving with V, right? So what happened? So the velocity of this block start to decrease and it will start to gain velocity. This block will start to gain velocity. Are you getting me? Okay. And it will happen till both block have same velocity, right? So as this is start to decrease, this start to increase, right? And a situation will happen when they start to move with V1 and this also start to move, let's say, with V1, right? And at this point, what will happen? Again, the force will be acting because this spring is already compressed. So at this point, we can say the x is maximum. Why? Maxi X is maximum. Why I'm saying this? Look, initially when this velocity is more than this, so it will be compressing this. But as soon as these two are equal, this will be the maximum compression. What will happen? This V1 will keep on increasing and this V1 is keep on decreasing. So hence this will start to stretch the spring and hence this compression will start to decrease. Are you getting me? Right? So this compression start to decrease and hence what will happen after some time? This will stop so it will be 0, and the spring will be in its original length, and this will start to move with V. Okay, and then again situation will come. So this will start to stretch the spring. Same situation will happen. It will start to gain a velocity in the backward direction, and then it will start to move in. So after a certain time, what will have start to happen? They start to move in with V. This will come to at rest, right? So it will go like this. Then so it will start to do like oscillations. Okay. So it is SHM or not, we have to check. Okay, let's see what the question is asking. The kinetic energy of A and B of A and B system at maximum compression is zero. No, at maximum compression they have some kinetic energy. So A option is wrong, right? A option is wrong. The kinetic energy of A and B system at maximum compression is mv square by 4. Let's check. So initial energy is half mv square. So we'll use the energy conservation. So initial energy is half mv square, right? And the final is 2 half mv1 square. Okay. So this will get cancelled and it will be divided by 2. What we have to find at maximum compression, the kinetic energy of A and B system is mv square by 4. Kinetic energy of okay. So yes, I have done some mistake here. What? So look, initially they have half mv square, then the final energy will be 2 half mv1 square plus they must have some spring potential energy, right? So it will be stored in the spring. Now, how will we find v1? Right? So let's use, if I make this system, there is no external force. So let's use the conservation of momentum. So it will be mv is equals to 2mv1. So this will get cancelled and we'll get v1 is equals to v by 2, right? So let's put it here. So we have half mv square is equals to, so what I have to find? I just have to find the kinetic energy now, right? So I'll just move it. So we'll just find the kinetic energy of the system. So kinetic energy of the system will be twice of half mv1 square. So it will be 2 half mv square by 4. So this will get cancelled. We'll get mv square by 4. So B option is correct, right? Now maximum compression of the spring is, so now I have to use this. So let's use this. So I'll get half mv square is equals to, this is mv square by 4. V square by 4 plus half kx square. So this will be 2, this will get cancelled. So it will be mv square by 2 is equals to kx square. So we'll get x as v root m by 2k. This will be the maximum compression. So C is wrong, D is correct. Okay, so B and D are the options. Let's move on to C and D, shall we? Okay, so this was our 10th, and this question is our 11th, right? So a ball hits the floor and rebounds after inelastic collision. Okay. The momentum of ball just after the collision is same as just before the collision. So that is wrong, right? Because on the ball there will be a force acting. So momentum of ball will definitely change. So A is wrong, right? The mechanical energy of ball remains the same in the collision, right? So is this correct? So in this question, there is nothing given about how the collision is happening, right? So look, if the collision is inelastic, then some energy must have wasted, some energy must have stored in a form of deformations. So nothing is given. So B is wrong. Okay. So mechanical energy of ball will not remain constant, right? It may be possible that Earth have bent, right? So Earth may have squeezed, so some potential energy must have gone to Earth also, right? So B is wrong. The total momentum of pole and Earth is conserved. So this is correct, right? So if I'm saying, let's say this is Earth and this is pole, and the whole, if we consider whole as a system, there is no external force, so total momentum of pole and Earth is conserved, definitely. So C is correct. The total energy of pole and Earth is also conserved. So this is also correct. Why? Look, if this is a system and we say this is an isolated system, we say isolated system, right? The question in this saying the ball hits the floor. So we'll consider that only we have Earth and the ball. So if this is an isolated system, the total energy of pole and Earth must be conserved, right? Where should an energy must have gone from out of the system, right? So C and D are correct. So for 33, C. Okay, let's move on to our 12th question. So we have this. Okay, a shell is fired from a cannon with a velocity v at an angle theta. So v at an angle theta. So it goes like this. Okay. At the highest point, it explodes into two equal pieces of equal mass. One piece retraces its path. So it breaks into two equal parts. So say this is m, this will be m by 2, and this m, right? And the one piece retraces its path back. So what happens? At highest, the particle of mass m will have only v cos theta. And finally, what is happening? This m by 2 will have in the opposite direction v cos theta. Okay. So question is incomplete. Let me get the question. And the speed of other piece. It's asking other the speed of other piece is what? Okay. So this is again simple question. Let's say this is m by 2. Let's say its velocity is v dash. So we'll just use the conservation of momentum. So it will be, let's say this is negative. So this is positive and this is negative. Okay. This actually is negative. So initial momentum is equals to final momentum of the system. So initially will be mv cos theta is equals to m by 2 v cos theta minus will be plus m by 2 to v, right? So we'll get 3 mv cos theta by 2 is equals to m by 2 v. M by 2 will get cancelled. So v dash, that's v dash, right? So v dash will be 3v cos theta, right? So it was A in this option. So it would be 3v cos theta. Okay. Again, quite an easy question. Yes. Let's move on to, this was our 12th. Let's move on to our 13th question. 13th question. So we have this. Okay, so we have a projectile thrown from a point O on the ground at an angle 45 degree. So again, we have a projectile with a speed of 5 root 2 at an angle 45 degree. Okay. Now again, at the highest point, let's say this was the projectile. So at the highest point, it splits into two equal parts. So again, the same thing, I guess. So this is m by 2 and we have m by 2. One part fall vertically down to the ground. So let's say it is start to move downward with a velocity v. Okay, right? And it takes 0.5 second after the splitting. So it is taking the time 0.5 seconds, right, to reach the ground. The other part takes t second after splitting, falls to ground at a distance x meter. So this part, uh, so it start to move like this, and it will move a distance x and it is taking a time t. So this is other half and this is the first. Okay. Okay, perfect. So look, as at this point, at the highest point, they will have a velocity v cos 45 here. Okay. So let's say this is v1 and v is this, right? Perfect. So if they have only the horizontal momentum, then the sum of vertical momentum should be zero. So this particle must have a velocity v2 in the upward direction. Are you getting me? And if there is no horizontal velocity, so let's just conserve momentum in the horizontal direction. So P initial x, P final x. So in the initial, we'll have mv cos 45 is equals to. So in this particle, it does not have any horizontal final velocity. So only this will have. So let's say this is v dash. So it will be m by 2 v dash, right? So m will get cancelled. So v dash will turn out to be v 2v cos 45. So it will be 2 into 5 root 2 into 1 by root 2. So this will have 10 meter per second. Now, the question is how we'll find V1. So we have time and we have the height. Okay, so let's find it. So height is what? So it will be u square sine square theta by 2g, right? And u was 5 root 2. So it will be 25 into 2 into sine square theta. So it will be 1 by 2. And this will be 2 into 10. So this 2 will get cancelled. And this will be 1.25, right? Okay. So h will be 1.25. Now let's just check if this is a v1 is 0, this v1 is 0, then will it take time? Okay, so let's just find. So we have the height, right? We have the height. So we'll find the v1. So which equation should we use? There is no equation, right? Yes, so second equation we can use. So h will be equals to v1 into t plus half into 10 into t square. So h is 1.25 is equals to v1 into 0.5 plus half. This is 5t square, right? And the t is 0.5, so this will be 25 by 100. And look, this will get cancelled. So we have v1 is 0. Now, some of you must take v1 0 and then solve it. But be careful. v1 might not be 0. In this case, v1 is 0. Okay. So this is the correct way to solve. So actually v1 is 0. So it just start to drop down. Okay. And this v2 is also 0 because in the vertical direction there is no momentum. Right. Now the question is very simple. We have a particle. It moves like this. So look, t we get 0.5 seconds. Right? And if this is a particle, it is also at a height 1.25 meter, right? And it moves like this. So again, the time will be same for this, and its velocity is 10 here, 10 meter per second. So x will be simply 10 into 0.5. So it will be 5, 5 meter. So x is 5 meter. So in this t we also have to find. So actually t will not be 0.5. Why? Look, read the question. The other part takes t second after the splitting, falls to the ground, right? So it will take okay, so yes, so t will be 0.5. After the splitting it is asking. Let's check x. It's falls to the ground at a distance x meter from point O. So this was our point O. So x will not be 5. So x will be this. So let's say this is y. So x will be actually x will be r by 2. That range, this is r by 2, right? So this will be r by 2 plus y. And this we have y. This we got y. So it will be r by 2 plus y, right? Now let's find the range also. So we have to find the range. So range will be u square sine 2 theta divided by g. So it will be u square will be 50 sine 2 into 45. So it will be 1. divided by 10. So this is R is 5. So R by 2 will be 2.5. Let's put all those values here. So 2.5 plus 5. So answer will come out to be 7.5 meter. So this will be the X. So the question is missing. So we have to find X for 41 and T for 42. So this will be the answer. Okay. So be careful. The X is meter from the point O. From the point O. So X will be this total. So it will be R by 2 plus 1. Okay. Again. So these were our 13th and 14th question. Let's move on to our 15th question. Sorry. So we have 15 question. Uh, okay. We have a solid horizontal surface is covered. Let me check. What's here. Covered with a thin layer of oil. So with thin layer of oil, a rectangular mass m 0.4 kg is rest on the surface. Impulse of 1 Newton second applied to the block. Okay, so velocity is given like this. So velocity is v naught e to the power minus t by tau. So initial velocity is 0. Velocity at t equal to 0 is 0, right? Start moving. Okay, perfect. So and okay, so the situation is, look, if you put t0, then look, if you put t equal to 0, this will be 0 is equals to v naught. So v naught will be 0, right? If v naught is 0, then velocity will not change. So that is wrong. Why? This impulse just before and after, right? So let's say this is t equal to 0. So just before, the velocity is definitely 0, but just after, velocity is not 0, right? So what is saying, this impulse is changing the momentum, changing the momentum. Are you getting me? Changing the momentum. So that means, so whatever the force is acting, it is impulsive force. Okay, so this is impulsive force. So within instant, it is changing the momentum. Okay, so we have to find the displacement. For that, let's find the v naught. So we have impulse. Impulse is what? It is change in momentum. So delta p. So it will be just after, just after, uh, right? So it will be just after, we'll say, let's say it is just after, it is v1, and just before it is, let's say, v naught. No, not the v naught. Let's say it's v1. So it's v1, so vi, and this is v final. So we'll write impulse delta p as v final minus v initial. Okay, right? And after the impulse, the velocity change like this. Okay, and everything we are talking about at equal to 0. So impulse is how much? It is 1 Newton second. So this is 1 Newton second. And v final velocity will be like this. So v naught e minus t by tau minus initial was 0. Okay, are you getting me? And now if we are talking about t0, so we have to put t0. So we'll get m into v naught. So this will be 1 is equals to 1. Right. So this is quite interesting. Yeah. So let's put m 0.41 into v naught. So we'll get v naught as 10 by 4. Okay, are you getting me? So just before the impulse, velocity is 0, but just after, still at t equal to 0, right? Still at t equal to 0, the velocity change like this. So that is why I have to write the momentum like mv final minus m initial. So v final I have to put this, and we are talking about t equal to 0, right? So v naught will be 10 by 4. Now the displacement we can find, right? So as we know, the final velocity is changing like this. So for velocity, we can write it as dx by dt will be equals to v naught e to the power minus t by tau, right? So dx will be v naught e to the power minus t by tau dt, and we integrated. So this will be the displacement which we required for the time 0 to tau. So 0 to tau. So this will be v naught e to the power minus t by tau minus 1 by tau. It will be from 0 to tau. So let's put those values. So v naught was 10 by 4, and this will be tau. Tau is actually 4. So it will be minus 4. And if you put tau, this will be e to the power minus 1. This will be minus 1. So this will be 4, 4 will get cancelled, minus 10. This is 0.37 minus 1. So we'll get 10 into 0.63. So this will be 6.3 meters. This will be our displacement. Okay, right? So this question is quite interesting to understand how the momentum affects the so how the impulse affect the momentum. Okay, right? So this was our 15th question. Let's move on to our. So let me erase this. Sorry. So let's move on to our 16th question. Now, in this question, we have two masses m1 and m2. Okay, connected by light spring of natural length L0, which is compressed completely and tied by a string, right? The system, while moving with a velocity v0 along positive x-axis, passes through the origin at t equal to 0, right? Now at this position, the string snaps. The position of m1 at t time is given by this equation, right? So we have to make the situation first. Okay, okay. So look, what is happening is, let's say this is our x equals to 0. These are the two blocks which are compressed completely. Okay, so compressed completely, right? And they are tied with a string. They are tied like this, and they have a velocity initially v naught. So this is m1, this is m. Then what happens at t equal to 0? This string is cut. Now what will be happening on this m1? There will be some force, and similarly on this there will be some force, and hence the velocity will be changing. The position will also be changing. In this question, it is given the position of m1 change like this. So we have x1 is equals to v naught t minus a1 minus cos omega t. Right? We have to find the position of particle m2 as a function of time. Now look, as f external is 0, so momentum must be conserved. So we'll say initial momentum of the system must be equal to final momentum of the system. So initially it was m1 plus m2 into v naught, right? The final momentum will be, let's say this has a velocity v1, this is m1, let's say this is v2, this is m2. So we'll write m1 v1 plus m2 v2. So direction you don't have to worry about. The question will automatically give. So if this is x1, how will you find v1? So it will be dx1 by dt. So it will be v naught, and this minus a will get cancelled. So it will be a minus sine omega t into omega. So it will be v naught minus a omega sine omega t. This will be v1. Are you getting me? So let's just put it here. So we'll have m1 plus m2 into v naught is equals to m1 v naught minus m1 a omega sine omega t. plus m2 v2. So m1 v0, m1 v0 will get cancelled. So we'll left with m2 v0 minus m1 a omega sine omega t. This will be divided by m2 plus is equals to v2. So this is our v2. But we have to find the position of particle m2 as a function of time. And we know this will be dx2 by dt, right? So dx2 by dt. So we'll just integrate it. So we get dx2 will be v0 dt minus m1 a omega by m2 integral sine omega t dt, right? So initially x equals to 0, t is 0. Now at certain, let's say it is x2, t is t, right? So let's put those values. So we'll get x2 is equals to v0 into t minus. Now integration of sine is plus, so it will be plus a omega by m2 divided by omega. So cos omega t, 0 to t, right? So the integration of sine omega is negative, right? The minus minus will be plus. Okay. So we'll get from here, we'll get mm, so if this goes here, this will be plus. So this will be plus. Now this will be minus. Now this is correct. Okay. So x2 will be v naught t omega omega will get cancelled. M1 a by m2, and this will be 1 minus cos omega t, right? So this will be the x2, right? So this was our first. Now the second is L naught in terms of a we have to find. L naught in terms of a. So L naught was what? L naught was L naught was our original length. Original length. How will you find original length? Look, what happens is the spring start to apply force. So this V1, so let's say this is V naught, right? This was V naught initially. So this start to decrease and this start to increase. Let this start to increase, right? Okay. So what happens? So we know this start to increase and this start to decrease. Okay. And due to this spring start to stretch, and hence at a moment they will come to their natural length. And when they come to their natural length, then the force applied by spring must be zero. Must be zero. If the force on due to spring is zero, then on each block m1 and m2, acceleration must be zero. Are you getting me? So let's just find the acceleration for any one. Okay, so let's just find the acceleration of x1. So we have v1 as this. So we have v1 was v naught minus a omega sine omega t, right? A omega sine omega t. Let's just differentiate it with respect to time. So we'll get acceleration of 1. So this will be 0 minus a omega square cos omega t. And let us make it a 0. Right? So let us make it 0. What do we get? So cos omega t will be 0 when omega t is pi by 2. So time period we get pi by 2 omega. So at this time the acceleration will be 0. Right? Now at this time the position of m1 will be, let's say, x1, and the position of m2 will be x2. So the natural length will be x2 minus x1. Right? Are you getting me? This is quite interesting question. So we have to find x2 minus x1, which will be equal to L naught at t equal to pi by 2 omega. Okay, so let's put x2. So it will be this, right? So it will be v naught t plus, right? So let's put these values. So it will be v naught t plus m1 by m2 a 1 minus cos omega t minus x1. So uh, x1 was this. So it is v naught minus a. So it was v naught t minus a 1 minus cos omega. So right. So if you put t equal to pi by 2 omega, so this will be 0. So this will become 0. This will become 0. And these will also get cancelled. So we'll have m1a by m2. This will be plus a, and this will be so this will be plus a, right? This is our L naught, right? So L naught will come out to be a 1 plus m1 plus m2. So m1 plus m2 plus m1 by m2 plus. Okay, this question is quite interesting. Again, let's move on to question number 17th. Okay, so we have question number 17. So this is our 17th question. Now in this question, we have a car. We have a car moving with the uniform speed of 5 root 3, okay, towards a carriage of mass. So this is the carriage, 9 kg kept on the rails at a point B as shown in the figure. The height AC is 120 meter. The cannonballs of mass of 1 kg fired from the car with the initial velocity 100 meter per second at an angle 30 degree with the horizontal. So this is a cannon which is firing a ball with 100 meter per second at an angle 30 degree. But this carriage is also moving with the speed of 5 root 3. Okay. So after a time t naught and sticks to it. So we have to find. Look, now this cannon will have velocity here 100 cos 30 plus 5 root 3, right? And above it will be a velocity. It will have velocity 100 sine 30 degree. Now, okay, are you getting? Now, this ball has to travel like this and reaches here. So, so in y direction, it has covered a distance minus 120, right? So in y direction in x. In y direction, so displacement in y is minus 120. Okay. Now let's to find t naught. So let us use this equation. S is equals to ut in y plus half ay t square. So sy is minus 120. So uy is this. So it will be 50, right? So 50 into t naught plus half minus 10 into t square. Okay. So 0 will get cancelled, and this 2, if we multiply, this will be minus 24. This is 10 t naught, and this will be minus t square. So we'll get t square minus 10 t naught minus 24. Right? So we can say t square minus 12 t naught plus 2 t naught minus 24 equals to 0. So from here we'll get t equal to 12. Okay. So t naught we get as 12. Right? So first part is over. Now The second cannonball is fired. Assume the resistive force between rail and carriage is constant, okay, and ignore the vertical motion of the carriage throughout. The second ball also hits the stick of the carriage and stick to the carriage. Okay, so what happens is, look, after a time t naught, this carriage, let's say, has a moved distance x, right? So this cannon has a move by distance x. So this carriage in that same t naught time, which is 12 seconds, must have moved by distance x, right? Okay. And because the second ball is moving like this, right? And this carriage is moving like this. So this must have also moved by distance x. And the force acting on it is constant, which is the resistive force. So let's first find the velocity of this carriage. Let's say this is v1, v dash. So initially momentum was 0 plus the ball was 1 kg, so 1 into the velocity of the ball was in the horizontal direction we have to apply. So it was 100 is this will be 50 root 3 plus 5 root 3. So it will be 55 root 3, right? So it will be, so momentum will be 55. So P initial in x direction equal to P final in x direction. The momentum is of first ball plus carriage, right? So this will be first ball and carriage. So it will be 0 plus 1 into 55 will be 10. The total mass will become 10, right? Into, let's say this is V dash. So V dash will be 5.5 meter per second. Okay. Now this velocity is decreasing, of course. Yes, this velocity is decreasing, right? And during this time, 12 seconds, it must have moved by distance this same, right? Then only that ball will hit on the carriage, right? So this was 55 root 3. So it will be 5.5 root 3, right? Uh, okay, meter per second. So are you getting me? Right? So during this T naught time, the interval will be T naught to 2 T naught, right? So during this time, let's say this carriage has moved X distance. So this cannon has moved by distance X. So this carriage must have moved by distance X. Okay. Now the initial velocity is V dash, and the let's say the acceleration is A. So the let's find first this distance X. So X will be 5 root 3 into 12. So it will be 60 root 3. Yes. So this X I have calculated from this because it is moving with a speed of 5 root 3. Now let's put this in this equation. So we have for the carriage, we'll use the second equation again. So it will be X equals to ut plus half a t square. So X is 60 root 3. U is how much? So it will be 5.5 root 3 into 12 plus half. Acceleration will be in negative direction and t will be 12 square, right? So how much it will be? So it will be, this will be negative and this will be 66, right? So 5, yes, 66. So this will be minus 6 root 3 is equals to 1 by 2 minus a into 144. This will get cancelled and this will be 12, right? So we have acceleration will come out to be, of course, acceleration will be negative. So if you just put it positive, so we'll get the negative acceleration, right? So it will be root 3 by 12. Yes, so acceleration will be root 3 by 12. Now, let's say this carriage has moved here and it is now moving with the speed of v2. So let's find v2. So v2 will be v dash plus at. So v2 will be, uh, this is 5.5 root 3 plus minus root 3 by 12 into 12, right? This will get cancelled, so we'll get 4.5 root 3. So this will be the final velocity of this carriage when one ball was here and the other ball was just about to hit. Just about to hit. Okay. So again, we'll use the conservation of momentum. So we will be having the ball moving with in the horizontal direction. So again, so initial in horizontal momentum or in horizontal, final in horizontal direction. Okay, so it will be 55 root 3 plus carriage plus ball was 10. So it will be 10 to 4.5 root 3 and the final all will stick together. So it will be 11 V final. So V final will come out to be 100 root 3 divided by 11. So V final will be this. So it will be approximately 15.75 meter per second. Okay. So this momentum I have conserved for this. So this is our carriage. A ball was already here and another ball was coming with the horizontal speed 55 root 3 and this is moving with the speed v2 which is 4.5 root 3. Okay. The mass of this is 1 kg and the mass of this is 10 kg. And finally what happens, this is our carriage. It's moving with the speed v final and both the ball are here. So I've used the momentum. Okay. So situation is quite interesting. At this point you have to understand that when the second ball was projected, so one ball was already here, and when the second ball was projected, okay, so second ball was projected, so whatever the distance this has covered during that t naught time, this must also have covered, otherwise this ball will not reach here. Okay, so this was the concept we have to use. Then we have find acceleration. With that we have find the initial velocity of the carriage just before the second ball hit, and then we have solved it. Okay, so this question is quite interesting. 17th question, right? Okay, I think I should stop here because the video is already getting a bit longer, so let's just stick to the 17th question till in the next video we'll cover more questions. Okay, thank you, bye bye.